You know, if you had to guess the single most important piece of tech in your home, you'd probably say your phone, right? Or maybe your computer? Well, what if I told you it's actually that simple metal box probably hidden away in a closet or down in the basement? Today, we are pulling the cover off that unsung hero, the electrical panel.
Yep, that breaker box. It is the critical command center for all the electricity flowing around you, pretty much all the time. It's the gatekeeper for both power and, maybe more importantly, for safety. So in this explainer, we're going to uncover exactly how this crucial device works.
So at its core, you can think of an electrical panel as the ultimate traffic cop for electricity. It takes that big main power line coming into a building and just masterfully directs it into smaller, more manageable circuits, for your lights, your outlets, all your appliances. But it does way more than just direct traffic. It also keeps everyone on the road safe.
And that right there is its most critical mission, to be an intelligent gatekeeper. See, it's not just some passive junction box. No. It is the active guardian making sure your entire electrical system is safe and reliable.
The central nervous system analogy it's perfect, really. Just like your brain sends signals all over your body and triggers reflexes to protect you from getting hurt, the electrical panel sends power exactly where it needs to go. And at the very first sign of danger, like an overload or a short circuit, it instantly, in milliseconds, cuts the power. But here's the thing. The panel in your home, that's just one type. There's a whole world of specialized panels out there, and each one is engineered for a very specific job and a very different scale. So let's explore some of that variety.
Okay, so the simplest way to classify them is by voltage. You've got your low voltage, or LV panels. These are the workhorses that power our daily lives, right? In our homes, in our offices. But for these massive industrial sites and the utility power grids, well, for that, you need to step up to medium voltage, or MV panels. These things can handle thousands of times more power. Enough to run a small city from just one point.
And from there, the specialization gets incredibly precise. Take a motor control center, an MCC. That's absolutely essential in a factory because the huge burst of current it takes to start a giant motor would trip a normal breaker instantly. Or an ATS panel. That's a literal lifesaver in a hospital because it instantly switches to backup generator power during an outage. And a PLC panel? That's the sophisticated brain behind complex automation, coordinating hundreds of processes all at once.
So, what's actually going on inside that metal box? What are the key components that make it all happen? Let's pop the hood and take a look.
Now, don't let that simple exterior fool you. Inside is a precisely engineered team of components, and each one is playing a vital role in managing and protecting this incredible flow of electrical energy.
Let's break down this team. So, power comes in and flows along the bus bars. Think of these as the superhighways of the panel. They feed the circuit breakers, which are like intelligent soldiers, and they're designed to handle two different threats: a thermal trip for slow, creeping overloads, and a magnetic trip for the sudden, violent current of a short circuit. Contactors and relays act like automated traffic signals, while the metering instruments are the eyes, always monitoring the system's health. And finally, you've got surge arresters. These are the elite bodyguards, deflecting external threats like lightning strikes.
Okay, with so much power concentrated in one little box, how do we know it's safe? Well, because every single panel design is forced to go through a series of absolutely brutal, unforgiving tests. They're designed to prove it can handle the absolute worst-case scenario you can imagine.
Seriously, it's like an Olympics for electrical equipment, and failure is just not an option. Can it run at max capacity for hours on end without overheating? Check. Can it withstand a catastrophic short circuit, a virtual lightning strike inside the box without exploding? Check. Can its insulation hold back thousands of volts without breaking down? Check. And can it keep out the fine dust of a factory or the driving rain of a storm? Only the toughest designs pass.
And that last test, that gives us the IP rating, which is a really simple universal code for toughness. You've probably seen it before. The first digit rates how well it defends against solids, from something as big as a finger to microscopic dust. The second digit rates its defense against liquids, from a single drip to a high-pressure jet of water. The higher the numbers, the tougher the box.
And all of these brutal tests, they're governed by one global standard, IEC 61439. This is the international rulebook. It's the shared language of safety that guarantees a panel's performance and its construction quality, no matter where in the world it was made. It is the gold standard.
All right, now that we know how they work and, crucially, why we can trust them, let's just step back and appreciate the absolutely fundamental role these panels play in our modern world.
I mean, electrical panels are literally the unseen backbone of our society. They don't just power your home. They run the data centers that host the entire internet. They control the machinery that builds our cars. They keep the lights on in hospital operating rooms. They even manage the complex flow of energy from solar farms into the grid. I mean, without them, our world would just grind to a halt.
And this massive global industry is led by some real engineering giants like Schneider Electric, Siemens, and ABB. These are the companies designing the next generation of panels that form our electrical infrastructure. They're constantly innovating, making them safer, smarter, and way more efficient.
You know, as we race towards electric cars and smart homes and a fully digitized society, our demand for smarter, more resilient power is just exploding. So the real question is, how will this humble metal box, this unsung hero, have to evolve to safely and intelligently manage the immense power demands of our future?